In this video, we're going to go over lesson 2 for the summer assignment, which is on limiting reagent. Again, this should be review from your first year chem class. So if you already know how to do this and you want to skip right to the practice, that's totally okay. But if not, we are going to go through the notes here. And if you have any questions, it might be useful for you to go through the notes very carefully, watch the video, all of that. So limiting reagent or limiting reactant, same thing. Reactant and reagent are the same thing. It has to do with stoichiometry. And what you're doing is figuring out how much of what you start with reacts and how much is left over. If all of the thing reacts, then that will be the limiting reagent. If there's some left over, that's what we call the excess reagent or excess reactant. The amount of product that you can produce is dictated by the limiting reagent and how much you started with. So here is a little example that can illustrate this. We're making hot dogs, so our product is going to be a hot dog in a bun. If we start with 5 hot dogs and 4 buns, we can make 4 full hot dogs. Our limiting reagent is the bun because that tells us how much product we can make, and it is all used up. Our leftover hot dog tells us that it's the excess reagent. It did not determine the amount of full hot dogs we could make. So we really care about the limiting reagent in our chemistry world a lot more because it tells us how much product we can make, and when you are a chemist, you're often interested in a certain product. So what we're going to do in this video is go over how to find the limiting reagent and the types of questions you could be asked on limiting reagent. And then we'll talk about how to find the excess reagent and the type of questions you might be asked for that. So limiting reagent or limiting reactant, you always want a balanced equation. That goes without saying. You will have 2 givens because they will tell you start with this many moles of one substance and this many moles of another, or this many grams of one substance and this many grams of another, okay? But you're going to get an amount for each reactant. So what you can do is this part right here is a little trick that kind of makes it go faster, okay? So if you're actually asked to show the amount of product, you can't use this trick. I usually tell my students you should use this trick to figure out what the limiting reagent is and then erase it because those numbers don't mean anything. There's no science behind them, but it is a great way, a great shortcut to finding which of 2 substances is limiting. So let's get started on that. Okay, so I broke this problem up into different sections so that you can kind of break them into different parts in your mind. So the first part here is the same problem as the next 2 parts, but it's a different type of question. So we are considering the reaction of magnesium nitride with water to form magnesium hydroxide and ammonia gas. And then it tells us our 2 givens. If you did this reaction with 58.1 grams of magnesium nitride and 20.4 grams of water, and then it's going to ask us different questions about this information. The first question is write a balanced equation that describes the reaction. They give us the entire thing. We don't even have to predict products here. So we're going to do magnesium nitride, just writing the formulas. And water gives us magnesium hydroxide and ammonia. And then we balance that. And that's all we have to do for this problem. I don't even have anything to write in the notes for solving because it's just writing the problem and then balancing it. What I am going to do, just to make my life a little bit easier, is write my givens right underneath the reactants. So I know I have 58.1 grams of this and 20.4 grams of this. You do not have to do that. I just find it very helpful to have that in my reaction. The next part says, what is the limiting reagent? And that's when we can use this little trick. Okay, so for the little trick that I circled up here, you convert to moles of each reactant if it's not already in moles. So if they give you moles, you don't even have to do that. And then divide by the coefficient in the balanced equation. Now, when we do this, again, it's not any type of science when we divide by this coefficient, but the lower number after we divide will tell us which one limits. So it's really helpful, quick, easy trick. So what you'll do is you take your 58.1 grams of Mg3N2, and then you're going to divide by the molar mass. And that gives you this for moles of Mg3N2. What we're going to do then is divide by the coefficient in our balanced equation. So if you go up to the balanced equation that we did, the coefficient for Mg3N2 is 1. So for this one, we just divide by 1. And so that's going to give us this, obviously. I'm going to do the same thing for water. And then I go up and find out what my coefficient for water is in my balanced equation, and it is 6. So I will divide this number by 6. And that gives us this. Now, all we have to do here is compare these two numbers. The lower of the two numbers is going to be our limiting reagent. So obviously our limiting reagent, 0.189, that came from water. So water is our limiting reagent. However, these numbers now mean nothing. So again, I usually tell students what they should do is figure out what the limiting reagent is and then erase this so that you do not get confused. So all I'm going to do is erase my division by that coefficient so that I don't go back and try to use those numbers as my moles, because those numbers are not moles. They're moles divided by the coefficient. Okay, after you get really skilled at this, you won't need to do the erasing, but I really do find it helpful just to get rid of it right away, because now our question is, what mass of each product can you make? And you can use your moles that you already found to start these stoichiometry problems, but you cannot use those fake imaginary numbers where we took moles and divided by the coefficient. So if you do that, it will really throw you off, and a lot of people will do that just by mistake, and then they'll get the wrong answer even though they do know what they're doing. So for mass of each product, we're going to find the mass of MgOH2 and the mass of NH3. You have to start with the limiting reagent for each of them. Okay, so you can start with 20.4 grams of H2O and then go from there, or you can make it a little shorter on yourself and start with the 1.13 moles of H2O, since you already know that's how many moles you had. So 1.13 moles of H2O, and then I'm going to convert that to grams of each product. Whoops. So that comes out to 33.0 grams of MgOH2. And I'm going to do the same thing for ammonia. So I'm going to start with my moles of water, because that's my limiting reagent. Oops. And then that comes out to 6.42 grams of NH3. So our answers are like that. This is also what we call the theoretical yield. So if we were doing a percent yield problem, we would need to find, and it didn't give us the limiting reagent, we would need to find the limiting reagent, use that to get the product amount, and then plug that into our percent yield formula. So you notice on the hot dog graphic, I did write the theoretical yield here. So just if that does come up, that's how you find it. You always use the limiting reactant. So now let's move on to excess reactant. The other reactant, not limiting, will be the excess reactant. Some of it will be left over. So usually you will figure out what the limiting reactant is, just like we did before, and then you will know what the excess reactant is. The type of question you'll be asked for excess reactant is usually something like, how much of your excess reactant is left over? So we're going to go over that right now. Okay, so we'll start with writing the balanced equation just like you always do. So here we're going to do phosphoric acid with aluminum, and then they give us the products as well. So phosphoric acid plus aluminum, aluminum phosphate, and hydrogen gas. Remember, hydrogen is a diatomic. So there's our balanced equation. So now we find out which reactant is in excess. Is it the acid or aluminum? We're going to do the same exact thing we did to figure out above which one was limiting, except we're going to pick the other answer. So I'm going to convert the grams, and I'm going to go ahead and write it underneath so that I have it easy to see, of each reactant into moles of that reactant, and then divide by the coefficient. And then we divide by 2 because that's the coefficient in our balanced equation, and we get this. I'm going to do the same thing for aluminum. And we get this. So then we compare these two numbers and see which one is lower for the limiting and higher for the excess. So our limiting reagent here is going to be our acid because 0.009 is lower than 0.0122. So for the question, it asks which reactant is in excess. And we know it's aluminum. So now that I've answered that question, I'll go ahead and delete the dividing by the coefficient part so that I don't get confused for any future questions. So then we get to the usual typical excess reagent question. How many grams, or sometimes it will say moles, of the excess reagent are left over? So to find that, you need to find out how many grams were used up and then subtract from the amount you started with. And again, just like with the last question, we always start our stoichiometry for any other question with our limiting reagent because then we know that was all used up. So what I'm going to do is take my moles of H3PO4, but this time I'm not looking for an amount of product, I'm looking for the amount of the other reactant. So I'm going to do the same thing, just a regular stoichiometry. And then obviously we're going to AL because that's our excess reagent. That comes out to be, this is the amount that reacted. So the whole thing here is if this much H3PO4, 0.0186 moles of H3PO4, we know that it reacted entirely. So then how much aluminum was used up? This much aluminum was used up. That is not what the question is asking. To figure out how much is left over, you take the grams that you started with of aluminum and subtract the amount that was reacted. And so that is going to be our answer. So that's it for limiting reagent. Again, you can watch this as many times as you need, and then you can go ahead and try the practice problems. For limiting reagent, for the first page of the limiting reagent practice, I just do moles to make the stoichiometry a little bit easier as you're starting to get the hang of limiting reagent and how those types of questions are asked. And then for the second page, I give you grams, which is more typical because we can measure grams in the lab. So that's more typical, but I want you to get the easier math to get the concepts of limiting reagent down.